I'm going to turn this pipe here into a musical instrument. Not like that. Like this. I recently built this weird keyboard here. This was the first keyboard I built, so I didn't know how easy it was to build keyboards, or I guess you could even say just things with buttons. It gave me the idea to make a MIDI-based, playable sequencer something, kind of like a guitar almost, a playable MIDI sequencer out of various knobs and things, because this thing was so easy to build, a wireless Bluetooth keyboard. I'm sure we could make something work. Right? I mean, it wasn't that easy to build, but that's a story for another day. So that's the whole brain of the operation there. That's the microcontroller that handles all the Bluetooth inputs and outputs. Basically, he's going to be able to take any weird little switch we want, like these toggle switches here. We've got these little mini ones. And we've also got these rotary switches. So these are like 4 selectable ways they can be. We got 3 of those. We have a whole bunch of key switches too. Here's the specification document for how things are going to flow through the system. So we've got the pipe here, and the pipe sends Bluetooth signals to the computer about what keys are being pressed and in what order, and the computer turns that into music. Simple, right? Here we've got various little keys for the key switches. We've got some more key switches. We've got some key switches plus toggle switches. We've got knobs and key switches, and inside the pipe, we're going to hide all the wires and the microcontroller and the battery, because I want this thing to be a standalone, playable, I want to stand up and play this thing. Maybe we'll even attach a strap to it, so you can just sort of like play it like a guitar, have it hang in there. So here's what I'm thinking more specifically. We would have one key switch for each note. We'll start with just the C major scale, and then when you press it, it just plays the note. And we'll add in a sharp and a flat switch. So that'll work by you hit the sharp, then you hit the G sharp, hit a flat, hit an A flat. That way you can sort of just go hard on these ones, and then these ones here for when you need them. All right, so that's cool. That's kind of like a shittier piano almost. Not bad, like a keytar, like a keytar, but like keyboard guitar rather than a keyboard guitar. That's great, but let's take it a step further and do a bit of sequencer stuff. So with one of the rotary knobs, we could have it select which mode. So we'll have live play mode, which is what we just talked about. And we got a step record mode, which is more of a sequencer thing. So in step record mode, instead of when you press the key, it plays back the note. Instead, we're going to loop through the sequence here. And when you press the C key, it'll put a C note into here, move the arrow forward. And then if you press the E, it'll put an E note in there, move it a step forward. We might want like a blank step. So we'll have one for that. You press that, it skips it forward. Let's go for that. And then fill it out. And then it loops back around to the start. You could go on again, and I think we would stack the notes or replace the notes. Could depend on a switch. That's up to the later decisions. If we come over here and hit one of the playback buttons, it'll just step through and play the notes back in the order that we put them in. And the start button just sends the arrow back to the start. So if you wind up over here, it sends it back to the start. Awesome. Great. Good shit. But what if we want a bit of variety in the rhythm, right? So there'll be 2 ways to do it. First off, we got the rhythm keys here. And what they do is they just change the length of the note that we're going to put in, right? So first we hit the C note, and then we want to hit, let's go, hold down the half key, and then hit the E note. It'll put in sort of like a half E, and then move it still the full step, right? And then we could put in like a double long G, and I guess it would still move there. Maybe we can play with it. And then on top of that, we'll put like a 1.5 C. So that'll stretch to like there. These ones down here are just for like velocity. So normal would be sort of in the middle. Hard would be like a strong velocity, soft is soft. I think they're all going to have a bit of randomness to them. So a normal curve, and maybe normal sort of like shrinks the curve. Like, maybe it's like out this. Or another way we can mess with the rhythm is if we take another rotary switch, we can have that set the subdivision of our pattern here, right? So we could have it, instead of being 8 notes, we could have it be 4. And then so whenever you press one of the note buttons, it'll populate a whole quarter of the pattern. And then the half key would do a half, which is like this one here. And then it moves the steps by step like that. And then you could have like the N8, a 16, 32. Could even do one that's like divided into triplets, get polyrhythmic with it. That's all to come later. For now, we're just getting a basic understanding of how things might work generally. So we can just put keys onto the pipe. Keys and switches and knobs and dials. No dials. A cool thing about MIDI is that there's actually one MIDI signal isn't just one MIDI signal to one instrument. A MIDI signal can have, I think, 16 different instruments in it. So we can use that in this thing to switch between different instruments and control them all at the same time. You know, using one of the rotary switches, we choose which one we're inputting into, and then we can play them all back at the same time. And we could have like a rhythm section. We could have drums on one of them, bass, lead. They could all be playing together. Maybe you're hitting a switch to turn them on and off. And I'm sure we'll make some very fun stuff with that down the line. So these are two that I'm not as sure about how it's going to work. So I think it could be fun to have the idea of, if you ever use tracker software, you sort of chain these patterns together. You would set one of these up, and then you would maybe set up a second one, third one, and then in a chain of them, you would say, let's play the first one twice, play the second one, then play the third, then play the second again, and then that would all play back in that order. And I'm not too sure about the specifics of that yet. I think we'll just get some buttons and switches in an area on the pipe, figure it out later. And in the spirit of figuring it out later, I think we should also just have like a section that's, you know, any other buttons and switches we have left over, stick them on there. We'll figure out a use for them later, maybe. So I've been talking a lot about how we can try out a whole lot of different things, right? We can like have these buttons do something, but maybe we reassign them, have those buttons do another thing, change how it all works pretty much. You could do that with a traditional setup where the pipe is just sending MIDI signals to your DAW or whatever, right? Because you can send MIDI over Bluetooth, you can do MIDI over USB, you give like just a regular MIDI cable, plug that into your synth. That would work, right? It might slow down our iteration time because we'd have to like flash the microcontroller each time, so we'd have to plug it in, flash it. That takes time. You know, I'm not super comfortable programming in C, and it would be pretty tricky to get. I mean, not tricky, but you'd have to add like screens or LEDs to the pipe for a bit of feedback into what's going on, or you can probably get lost pretty quick. The way we're going to do things is with one layer in between. So the pipe, instead of sending a MIDI signal right to the DAW, is going to actually straight up be a keyboard. It's going to send keyboard inputs to our translation layer. And our translation layer is going to take those keyboard inputs and send them to the DAW. And in that translation layer, we can have visualizations, we can have indicators, we can have hot module reloading to just quickly swap it out, right? The pipe itself won't actually change once it's programmed as a keyboard. It'll just send the same key inputs, and we can interpret them in different ways. It's going to have a much faster iteration speed, and we can use JavaScript. Don't make fun of me. You know, I'll get there one day, but right now, I want to make a fun pipe. So that's the general idea of what we're going for. So first we're going to have to build the pipe, then we're going to have to program the pipe and just get that thing sending keyboard signals. Then we're going to build our translation layer, which will include the visualizations, converting those keyboard signals into MIDI signals. That'll be fun because we'll finally get some sounds out of it. And then from there, we'll just be implementing each of the things, like the dials to set the certain things. So it'll be mostly implemented in the translation layer. That's where a lot of the work will be done. But first, the fun stuff, we're going to boot up Fusion and do a bit of 3D modeling, do some 3D printing to get the whole pipe made up first. And our first step is going to figure out how to put this little key switch in. The keyboard model is what we're going to base it off of. So these just press in and you solder to the back of them. And if we come over here, this is the generator. And if we simply just abuse it a bit, then we get these single little key holders here. And that's great because this place is awesome and they let you download the CAD files. So we can just bring them in. And what I did was I just looked up in here at the little holes that you can kind of see it, that little square, and modeled my own. Right there, and we did it actually through cutting out the hole. So you can see this is going to be the key cutter. And you just drop that into anything and it'll cut the hole perfect to fit the little key. But first, we have to test it out. So I got this 3D printed up, as you can see here, and this is a live test fit. Ooh, like a glove. That's great. So that's our little key switch. Now we can come back to the pipe here. and design little key holders. We'll start with the notes here. So let's do the notes. All right, well, if it's 14, how far apart are my fingers? 23. That's that way, and then that way is maybe 20 millimeter. So we got 1, 2, 3, 4, 5, 6, 7. For a layout, does it make sense to sort of have the chord? Ooh. No, all right, so you have the 7th there. And those guys like that. Staggered? I don't think staggered. So as it continues, it's gonna be one you wanna hit a bunch. This is where you get a good advantage of. This can just be remapped in software, like no problem at all. So it's just a layout. So I think we're just gonna go for a grid, 5 by 2. How thick does it need to be? I guess it's gonna go in. So on top, it doesn't need to be very thick. So actually, we can go here, edit this. Okay, so we have the basic little piece that's going to go on top, right? So you have the nice curved bit to fit on top of the pipe and hide any little mistakes we have when cutting it up. And you have this nice big supportive block, flat part to print, and that puts the curve on top so you don't need that much support. And if we take a look at the pipe, so it just sits right up top there. We'll probably slide them down a bit on the actual pipe. Now, basically what we're going to do is bring in the key cutter. That'll cut the holes and just punch a hole. It seems huge. Fuck. All right, now all that's left to do is cut out the keyholes. We'll probably do a little 2 tester first, right? Rather than the whole 8. We'll just do a little 2 side by side because that'll, I mean, maybe it's not strong enough and you don't want to do a whole big print just to have it fail. Looks right to me. Maybe 17, -17. Okay, so after a good bit of fucking around, we've got 2 perfect little keyholes. So let's round that out a bit. Nice. All right, so what we're gonna do is I'm just gonna chop. Yeah, like up to there, maybe. Export this for a bit of 3D printing. And don't make fun of me for using Cura. I know, look, I know, but I learned it. I don't need to do any of that fancy stuff. If I ever get one of those fancy bamboo printers, I'll learn that one. Those are pretty thin, so we'll see how that comes out there, right? I'm worried about this thinness here on the edge, and I'm worried about the structural integrity of this guy here. So we'll see. We got our first test print off the 3D printer. It's I'm glad we did a test print. So it's got a couple of things wrong with it. This is way too thin. You see? I don't know what I was thinking. I guess I just didn't really take into account the thickness of like one layer. Like the sides here, they broke off immediately. Not great. Not great at all. In here, it seems okay. Like it's definitely like sturdy enough, right? Like this isn't going nowhere. All right, not bad. The keys go in. The keys stay in for sure. Those are not coming out. So one thing I'm noticing on the bottom here is that's going to be fucking nightmarish to solder to. Like you see how that, let's see, like that in there is so close to that plastic that you're going to melt that with a soldering iron. So you might want to just sort of swoop out this bit here. So it's more of a, I was worried about like structural integrity there, but it's just, it's rigid enough that I can definitely take away a good bit of that material for the soldering convenience. Look, but other than that, it's not too bad. We got a good fit. It seems like the angle's pretty decent. And I guess we'll fix up those couple of issues, do another test print. So if we take the lessons we learned from the little test sprint, first off, I added the extra 2 key cutouts because I realized I only had 4x2. And then we thickened this guy right up and also did a bit of a cutout here, right, along the bottom so it's not as flat, and that'll make the wires easier to solder. I also gave it a little bit of a curve on this side here, just to sort of ease how it's going to touch onto the pipe. But the little test guy's ready to go, and if this one turns out well, then we can go right ahead and print the full thing. Fresh off the printer, look at this one here. You can easily, we still got to clean up some of the supports, but this is much more promising. Like you can see, way sturdier, way nicer. Let's put some keys in there. Oh yeah, that's looking good. That's looking sturdy. All right. Well, I also printed up a couple of little keycaps. So you can pop on there. Just to see how they look, because I don't have any actual keycaps. But I don't think that traditional keycaps is the move for this thing. I think something a little bit more button-like this is good. I didn't make these ones, though. I just found these online. But it could be fun to make our own. We could have, it could be different shapes, sort of like a homing key, right? Where you feel it being different. They could be a little more molded to your fingers. That's nice. That's nice. Okay. I'm pretty happy with that. That's where we're going to leave it today. So come back next week when we'll be designing and printing the full pieces, probably even putting them into the pipe. That'll be fun. We get to drill into the pipe. So check back in, see how we're going. Let me know what you like. And if you got any tips for any fun things we could add in the transform layer, I'd love to hear them.